Imagine deploying an ESP-32 IoT device in the field, only to discover a critical library bug blocking your sensor readings or a missing feature that could have saved days of development. Open source contribution turns this frustration into opportunity. By engaging with repositories like ESP-IDF, you not only fix issues and improve code but also help thousands of engineers worldwide. This lesson will show you how to identify issues, create pull requests, improve documentation, and actively participate in the ESP-32 community. You'll gain practical skills that strengthen your coding, debugging, and collaboration capabilities while building professional credibility that can accelerate your IoT career. Think of open source as both a learning accelerator and a platform to make a lasting impact. Every open source project on GitHub begins with a repository, the central hub for code, documentation, and issue tracking. Forking creates your personal copy of the repository, letting you experiment safely without affecting the main project. When you find an issue or see room for improvement, you clone your fork locally, make changes in an isolated branch, and test them on your hardware. This workflow prevents accidental breakage of stable code while maintaining a clean path to submit pull requests. Reflect on this. If you had direct access to modify the main branch, would errors propagate to hundreds of users? Forking and branching protect both your work and the community. GitHub issues serve as the project's roadmap for bugs, enhancements, and documentation gaps. By reviewing open issues, you can spot opportunities to contribute where your skills are most valuable. Assign yourself to issues, comment with clarifying questions, and propose solutions in a structured way. For example, a bug report on ESP-timer could guide you to add a missing example or fix a subtle memory leak. Reflective question: how does analyzing open issues deepen your understanding of the project's architecture and design constraints beyond simply reading the code? Branches allow you to isolate work for each fix or feature, keeping the main branch stable. Naming branches descriptively, like fix DHT sensor or docs multi-timer, communicates purpose clearly. Once your change is ready and tested, you submit a pull request to the main repository. Include detailed descriptions, references to related issues, and concise commit messages. Maintain code style and formatting standards to improve the chance of approval. Reflective question: how does a well-structured PR improve maintainability and review efficiency for the project's maintainers? Contributing to open source goes beyond code. Bug fixes, feature enhancements, documentation improvements, reusable libraries, and community support all count. Fixing a sensor driver issue strengthens your understanding of hardware-software interaction. Adding an example to a README helps beginners adopt libraries faster. Reviewing PRs teaches critical evaluation skills. Community engagement builds visibility and may lead to professional opportunities. Reflective question: which type of contribution challenges you most, and how can it accelerate your technical growth? Suppose the ESP-timer API lacks a clear multi-timer example. Start by forking the repository, cloning it locally, and creating a branch named docs multi-timer example. Edit the documentation to add concise, tested code showing multiple timers with callbacks. Compile and run the example on your ESP-32 to verify functionality. Commit changes with a clear message referencing the issue, push the branch, and open a pull request. The expected outcome is a merged PR that provides future developers a working example, improving usability and reliability of the library. Avoid committing directly to the main branch. Always work in feature branches. Test examples on real hardware, since simulators may hide subtle issues. Follow ESP-IDF coding conventions and commit message guidelines to prevent rejection. Engage constructively with maintainers. Polite discussion increases chances of acceptance. Remember, contributing is as much about communication and reliability as it is about code quality. These practices make your contributions professional and maintainable, building trust in the community. To internalize open source contribution, practice with real projects. Identify an ESP-IDF issue, fix it, and submit a PR. Add a small helper function to a sensor library, or improve tutorial documentation. Review another contributor's PR and provide constructive feedback. Track your contributions for a month to reflect on skills gained and community impact. These exercises strengthen technical skills, collaboration habits, and your professional presence in the IoT ecosystem. You now understand the full workflow for contributing to ESP-32 open source projects, identifying issues, forking repositories, working in branches, testing changes, and submitting pull requests. You've seen practical examples of code, documentation, and community engagement, and learned the professional standards necessary for maintainable contributions. Applying these habits accelerates your learning, strengthens collaboration skills, and positions you as a recognized contributor in the global IoT community. Engaging with open source transforms your projects from isolated code into shared solutions with lasting impact.